If you notice that I make a mistake, please stop me. That way I could go back and correct it. That way it doesn't record as a mistake. But anyway, we're going to start right here with the parent graph, y equals x squared. And we should know that you could graph any equation with an xy table. And if you think about the x's, those are your inputs. So whatever numbers you put right here, you're going to plug into your x's. And obviously the easiest number to plug in would be 0. Plugging in 0, 0 squared is 0. And when you plug in a 1, 1 squared is 1. When you plug in a 2, 2 squared is 4. When you plug in a 3, 3 squared is 9. And those are coordinates, okay? Likewise, if you plug in a negative 1, you also get a positive 1 because negative 1 squared is positive 1. Negative 2 squared is also positive 4. Negative 3 squared is also positive 9. And what we end up with is this perfect parabola, 0, 0, with the coordinate 1, 1, with the coordinate 2, 4, with the coordinate 3, 9, and negative 1, 1, negative 2, 4, and negative 3, 9. So on this question, you have to plot these 7 points to get full credit. If you don't plot all 7 points, you're not going to get full credit. Now, this is the original parent graph that we started with, and I asked you to memorize these coordinates as a pattern from your vertex. 1, 1, 2, 4, 3, 9. Right? 1, 1, 2, 4, 3, 9. Or you could go in the other direction, 1, 1, 2, 4, 3, 9. You are going up because the A value is positive 1. If the A value would have been negative 1, you'd be going 1, 1, 2, 4, and you get the idea it's opening down instead of up. But anyways, I just wanted to explain that on this parent graph question. Let's move on. This is actually question number 3 on your assignment. How do we start graphing? You always start with the most important point, which is a vertex. And how do we find this coordinate? We use the formula, x equals negative b over 2a. And when you use this formula, I always say rewrite it with parentheses. And then, of course, identify your b value is 6 and your a value is negative 1. So put the 6 right here and the negative 1 right there. And when you do the math, you get a negative 6 up on top over a negative 2 on the bottom, which is a positive 3. Of course, we just found that x equals positive 3. So the x value of your vertex is positive 3. How do you find the y value? You simply plug it in to the original equation. So rewrite the equation. Y equals negative x squared plus 6x minus 9. And notice that I wrote parentheses instead of x's because I know what x is. X is 3. So you're plugging in a 3. And you could technically do all this math on the calculator, but I want to do 3 squared first. That's 9. Don't forget about the negative sign in the front. That just comes down and it's still a negative 9. Now when you multiply 3 times 6 or 6 times 3, you get 18. There's a plus sign in front of it. Bring down the minus 9 over here. And coincidentally, we end up with the negative 9 plus 18, that's positive 9. And 9 minus 9 happens to be 0. So we just found the vertex y value is 0. Okay? So you guys are going to have to do all this on your own right now. So I hope you guys are paying attention and taking notes. So let's plot this most important point, 3, 0. 3 on the x. 0 on the y. You don't go up or down. You stay right there. So this is your vertex. So you're going to plot a point on quizzes on Whiteboard like that. And then you can't really draw an axis of symmetry. Like normally if it were paper, you could draw your axis of symmetry going right through that vertex. But you're going to have to imagine it on your computer screen, right? So we need more points. And what we're going to do is use a pattern, 1, 1, 2, 4, 3, 9, that we got from the parent graph coordinates. But we're going to use it as a pattern from the vertex. Now, the question is, do I go 1 over 1 up? Because the a value is negative, that means that the parabola is opening down. So you're going to be going 1 over, 1 down. So you're going to go 1 over and 1 down, and you're going to put a dot right there. And it doesn't matter in which direction you go. You could go 1 over this way and 1 down. You're going to have to do it to both sides anyway. Okay. So the next part of the pattern is 2 over, 4 down, and it's from the vertex. So 2 over, 1, 2, 3, 4 down, and you'd be right there. And the last part is 3 over 9 down. So 1, 2, 3 over, and 9 down would be right here at the y value of negative 9 in this case. And of course, map it over to the other side. What do I mean by that? It's 1 unit, 2 units, 3 units away from your axis symmetry. So 1 unit, 2 unit, 3 units away would be right here. By the way, this is the y-intercept. Right there, that's where it crosses the y-axis. And the y-intercept, just for the record here, the y-intercept is the easiest thing to find when you have a standard form quadratic trinomial equation, because how do you find the y-intercept? Well, you set x equal to 0 and solve. And if you do plug in a 0 right here and right here, everything becomes 0 except the minus 9. So your y-intercept is 0, negative 9. But we already knew that from the pattern, okay? But it's just something that we are going to have to know in the future. And also map this one over 2 units away. So 1, 2, it would be a dot right there. And there's your perfect parabola. Whoops, let me put it in red. There's your perfect parabola opening down with the pattern 1, 1, 2, 4, 3, 9 with the vertex 3, 0. You're going to have to do that on your own on the next quiz that we have and on the homework assignment for today. Let's move on to the next question. Another quadratic. It might look a little weird because it doesn't have a c value, but that's okay. Sometimes you don't have a c. Sometimes you don't have a x term in the middle, which means your b would be 0. But in reality right here, you always start with the vertex. And you're going to use the vertex formula. X equals negative b over 2 times a. And when you use that formula, please rewrite it with parentheses the way it's written on the wall. Identify your b value. In this case, your b value is 4 and your a value is 1. So put a 4 right there and a 1 right there. You're going to end up with negative 4 over 2. And negative 4 over 2 is really negative 2. So your vertex x value is negative 2. How do you find the y? You simply plug in that negative 2, that x value of negative 2. You plug it in where your x's are at. So I'm going to rewrite the original equation, y equals x squared plus 4x. And I'm going to plug in that negative 2 into those parentheses where the x's used to be at, because x equals negative 2 from our formula. Then you do the math. You could do this with the calculator if you want. Negative 2 in parentheses squared is positive 4. Then you have 4 times negative 2, that's a negative 8. So you really have a minus 8. 4 minus 8 is minus 4. So your vertex y value is minus 4. So our vertex itself is negative 2, negative 4. It's the location, negative 2, negative 4. And we put a dot right there. Now is this opening up or down? Up. Why is it opening up? Because the a value is positive. To be specific, it's positive 1. And we all should know this by now, that when your a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9 from that vertex. But you got to know that because it's positive, it's going to be opening up, not down. It's going to be opening up. So let's do the pattern 1, 1, 2, 4, 3, 9 from this vertex. So 1 to the side, 1 up. You put a dot right there. Go back to the vertex. 2 to the side, 4 up. 1, 2, 3, 4. You're at actual origin right there. Then go back to the vertex and go 3 over 9 up. 1, 2, 3. So 4, 5, 6, 7, 8, 9. You'd be right there. And of course, you're going to map them over to the other side. So take this point. That's 1 unit away from being right on top of the vertex. So go 1 unit this way and put the dot right there. This one is 2 units away from being right on top of the vertex, which is where your axis symmetry is at. So go 2 units this way and put a dot right there. And last but not least, this one is 1, 2, 3 units away from being directly on top of the axis of symmetry, on top of that vertex. So go 3 units this way and you'll get to your final point right there. And I hope you guys appreciate this, because this pattern right here is saving us a ton of work, right? Like if we wanted to, we could go for an XY table and plug in the number 1, do all kinds of math, and you'd get the answer 4. If you plug in a 1, you get out of 4. You could plug in a negative 1, you get out of negative 3. So these are all coordinates, answers, x and y values based off of the pattern, which saves us a ton of time. This one's actually number 7 from your assignment today. Number 10 from our assignment today. Like always, let's begin with the vertex. The vertex is the most important point. It's a coordinate. And how do we find this coordinate? Well, you could find the x value using the formula x equals negative b over 2a. Always replace the b and the a with parentheses. That way you don't make any mistakes. After you do the parentheses, identify your b value is negative 18 and your a value is negative 1. So up on top, you have positive 18 because a minus minus changed to a plus plus. And on the bottom, 2 times negative 1 is negative 2. So what does x equal? X equals 18 divided by negative 2, that's negative 9. So you have your x value of negative 9. Now you still need your y value. How do you find your y value? You simply plug in the x value of negative 9 into the x positions right here and here. So you take that negative 9, plug it in right there and there. So I like to rewrite it And you should rewrite it with parentheses instead of x's. Y equals negative x squared minus 18x minus 74, okay? And plug in that negative 9 right there and right there. So when you do the math, do not change the minus minus to plus plus. That would be incorrect, because the rule of minus minus changing to plus plus comes from that a negative times a negative equals a positive. And we know we need to deal with exponents before multiplication on PEMDAS. So we are going to do the negative 9 in parentheses squared first. That's 81. The negative sign in the front is just going to come down and it's going to become a negative 81. And over here, we really do have a negative 18 times a negative 9. You could use a calculator. You're going to get positive 162. And then bring down the minus 74 at the very end. So right here, you're just adding and subtracting from left to right. Well, we have negative 81 plus 162. That's a positive 81. And positive 81 minus 74. 7 is the y value. So we have y equals 7. So the y value is 7. So there's your vertex, negative 9, 7. So let's plot that point, the most important point. You're going to go from the origin. You're going to go to negative 9. You're going to go to 7. And you're going to put a dot right there. Now, does this open up or down? Down. It's opening down because a value is negative. So we can use the pattern, because you could use a pattern 1, 1, 2, 4, 3, 9 whenever you have a 1 or a negative 1. So we're going to use a pattern 1, 1, 2, 4, 3, 9. It is opening down. So from this vertex, you could go 1 to the side, 1 down, and put a dot there. And then you're going to go 2 to the side, and you're going to be like, wait a minute, I can't move my dot on quizzes. You're not going to be able to get over here to negative 11. So you're kind of stuck there. And a lot of people are going to freak out and be like, what do? I can't move it this way. Well, the parabola does exist that way. It's just the graph's not big enough. So if you can't go this way, then go the other way. Instead of going 1, 1, 2, 4, 3, 9 off the graph, go 1, 1 onto this other direction. Back to the vertex, 2, 4, 2, 1, 2, 3, 4. Put a dot right there. And then 3, 9, 1, 2, 3. You got 7, 8, 9, put a dot right there. And I mean, if you tried to reflect it to the other side, 1, 2, that's right on top of right below the vertex. 1, 2, you're on the edge. Quizzes will not let you put a dot here because it's too close to the edge. But this is good enough. As a matter of fact, on this question, it'll say plot 5 points. That's 1, 2, 3, 4, 5. 5 points, and you get full credit. So don't expect that every single parabola is going to be perfectly on the XY plane. Some of them might be like way up here and you only get 3 dots. Some of them may be over here and you only get half of the parabola, like over here, and the other half goes off the graph. So this is a good example of it not landing perfectly on a 10 by 10 graph. Okay, we're going to get to some interesting questions as well. Listen to this one. This is a good one. It says plot 7 points, all right, of the graph of the parabola that has the range y is less than or equal to 8. What the heck does that mean, range? That tells you that your parabola is either at or above a certain value or at or below a certain value. So what does it say here? It's at or above or at or below the y value of 8? It's below 8. So I know that here's 8 on the y. I know that my parabola has to open down, but it might not be right here. It might be over here. Or it might be over here. But I know that it can't go higher than 8 because it has to be less than or equal to 8. All right, so the range usually comes from our vertex y value. So this is very important. Please pay attention. The range comes from the vertex y value. So if we know that the range is y is less than or equal to 8, we know that the vertex y value is 8. Does that make sense? Okay. And if that doesn't make too much sense right now, I'm pretty sure you guys understand what the axis of symmetry is. What's the axis of symmetry? It's the vertical line that crosses right through the vertex, right? So if you were to think of the vertical line at x equals 6, you should know that it's this line right here. Even though you can't graph it on quizzes, you should know that it's that vertical line right there through x equals 6, okay? So where does the axis of symmetry equation come from? It comes from the x value of your vertex. And the x value of your vertex is 6 in this case. You see how we kind of worked backwards from the information? if they give you an axis of symmetry, where does the axis of symmetry come from? It comes from the x value of your vertex. So indirectly, they're telling you the x value of your vertex is 6. The range is less than or equal to 8. So they're telling you that the highest point, the highest y value is 8. So they're giving you the vertex. So now you could go to 6, 8. That is 6 on the x, 8 on the y, and you put a dot right there. Okay. Now we need more points. And we know that this a value is -1, which means we could use a pattern 1, 1, 2, 4, 3, 9. You don't have to modify it. It is going down. If you wanted to modify it, you technically can, right? If your a value is not 1, all you have to do is multiply the outputs by that new a value. So if you wanted to, it's kind of silly, but if you wanted to, you could say, I want to multiply the outputs by -1, by -1, by -1. That way you'll get -1, -4, and -9. But what all that means is that you're going 1 to the side and 1 down, 2 to the side and 4 down, 3 to the side and 9 down. But you already knew that because it's opening down. Not only that, the range value is y is less than or equal to 8, so it has to be opening down. It has to be below 8. So let's use the pattern 1, 1, 2, 4, 3, 9 from this vertex. 1 to the side, 1 down, put a dot there, back to the vertex, 2 to the side, 4 down, put a dot there, back to the vertex, 3 to the side, 9 down, put a dot right there. And you could map them over to the other side. 1 unit, 2 units, 3 units, right below the axis of symmetry, right below the vertex. 1, 2, 3 this way, put a dot right there. Likewise, 1, 2, 1, 2, put a dot right here. And the last one is 1 unit away. So you get full credit with those 7 points. And we actually graphed this, not even looking at the equation, just understanding information of the parabola, which was the range and the axis of symmetry, and that the a values are -1. Let's try another. They want us to graph 7 points, and right here they tell us that the axis of symmetry is x equals 2, and they tell us that a maximum value is -1. What the heck does that mean, max value? Well, first of all, if I tell you the axis of symmetry is x equals 2, what does that really tell you with regards to the vertex? What does x equals 2, the axis of symmetry x equals 2, tell you about your vertex? That the x value is 2, right? The x value has to be 2. I mean, you can't have your vertex at -4, 2 if your axis of symmetry is over here. Your x value of your vertex has to be at the x value of 2. So you know 2 so far. Now, a max value, now we're talking about altitude, right? Like, let's say your parabola goes up, 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 and it reaches 10, then it comes back down, it would have the max value of 10. Or let's say your parabola was opening up, and it goes down, 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 and it reaches a minimum value of 2, then it goes back up. So the max and the min technically tells you if it's opening up or down, okay? When they say max value, like if you throw something up in the air, it's going to reach a maximum height, and then it's going to come back down, right? So max value insinuates or tells you that your parabola is opening down, and it says it has the max value of -1. So it's not going to reach 10. It's not going to reach 4. The highest value is going to be -1. And we know that the vertex is either the highest or the lowest value. So in this case, your vertex y value is -1. Okay, so -1 is right here. Does that make sense? I hope you understand that. The axis of symmetry indirectly gave us the x value of the vertex. The max value -1 gave you the y value of your vertex. Now, we already know it's a max value, which means it's opening down, but they do tell you that the a value is -1, so let's use the pattern 1, 1, 2, 4, 3, 9 from that vertex going down, not up. Why is it down? Because the a value is -1. So 1, 1, put a dot there, back to the vertex, 2, 4, put a dot there, back to the vertex, and we got 3, 9, 1, 2, 3, and 9 would be all the way down here to -10. And then, of course, you're going to map them over to the other side. Let me get some more space here. So this is 1, 2, 3 units away, 1, 2, 3 units away. This next one is 2 units away, so go 2 units this way, and you'll be right there. And the last one is 1 unit away, so go 1 unit this way, and you'll be right there. So you guys are all going to have to do this on the assignment and on the next quiz. Let's try another. Right here, we want to plot 5 points, and we finally get to some questions that we have to modify the pattern because the a value is -2. Let's begin by finding the vertex. And the vertex is a coordinate, and you find that x value of the coordinate using the formula x equals -b over 2a. And when you use this formula, please replace the b and the a with parentheses. Identify the b being -8 and the a being -2. So you put a -8 right there and a -2 right there, and then you do the math. Up on top, a -8 becomes +8. On the bottom, 2 times -2 is -4. 8 divided by -4 is -2. And we just found the x value of the vertex. The x value is -2. Anytime you have the x value and you want the y value, you simply plug it in. So I'm going to rewrite the original. The original says y equals -2x squared minus 8x minus 7. Here it is. Y equals -2x squared minus 8x minus 7. And plug in that x value of -2 that we found with the formula. Then you do the math. -2 squared is +4. But you still have to multiply it by -2. That gives you a -8. Over here, -8 times -2 is a +16. And you bring down that -7. From left to right, you have -8 plus 16, that's 8. And 8 minus 7 is 1. And we just found that y equals 1. The y value of the vertex, that is. So you go to the location -2, 1, -2, 1, and you put a dot right there. And now from this dot, we need more points. But we can't really use the pattern 1, 1, 2, 4, 3, 9 as is because the a value is not 1. The a value is -2. So what we're going to have to do is modify the outputs by multiplying the outputs by that new a value of -2. So instead of 1, 1, it's 1, -2. Instead of 2, 4, it's 2, -8. Instead of 3, 9, it's 3, -18. So this is your new pattern. Let me highlight it. 1 to the side, 2 down. Then you go back to the vertex, 2 to the side, 8 down. Back to the vertex, 3 to the side, 18 down. Okay? So let's actually use this modified pattern now to get more points. So 1 to the side, 2 down. You'll end up right here. And you could also map it over to the other side. And then if you go back to the vertex and you go 2 to the side, 8 down, 2 to the side, 1, 2, 3, 4, 5, 6, 7, 8 down right there. And you could map that over to the other side as well. 1, 2, 1, 2, and put a dot right there. And voila, we are done. We have 5 points. 1, 2, 3, 4, 5. That's your parabola opening down. Do you get it? Yep. Good. Let's try modifying and getting this new modified pattern with the a value of -3. First, find the vertex, which is a coordinate. How? By using the formula. X equals -b over 2a. And when you use that formula, rewrite it with parentheses. Identify your b value being 12, your a value being -3. You really have a -12 divided by -6, which is +2. So you have the vertex x value of 2. You're going to rewrite your entire equation, but instead of x's, you put parentheses because you know that x is actually 2. You're going to plug in that 2 right there and right there. And you do the math either with the calculator or by hand. 2 squared is 4. You still have to multiply by -3. -3 times 4 is -12. Over here, 12 times 2 is 24. Bring down the -5. So from left to right, if you owe 12 and you have 24, you're going to have 12 left over. If you owe 5, you're going to have 7 left over. So your vertex y value is 7. That's the most important point. That's the most work that you do on graphing any parabola. So let's go to the location 2, 7. 2 on the x, 7 on the y. And that is right here. Put a dot there. Now you need more points. Normally I would say use the pattern 1, 1, 2, 4, 3, 9. However, we're going to have to modify the outputs according to this new a value of -3. So you're going to multiply times -3 times -3 times -3. So you really get 1 times -3 is -3. 4 times negative 3 is negative 12. 9 times negative 3 is negative 27. So your new modified pattern is right here, highlighted 1 to the side, 3 down. Then you go back to the vertex, 2 to the side, 12 down. Then you go back to the vertex, 3 to the side, 27 down. But we're not going to use that one because you only have a 10 by 10 graph. You're going to be way off the graph if you go 27 down. So let's go through and go 1 to the side, 3 down, 1 to the side, 1, 2, 3 down, put a dot right there. Then you go back to the vertex, and you can go 2 to the side, 12 down. Or how about this? Like if I were going 1 to the side, 3 down, I'd end up right there. And if I went 1 to the side, 12 down, I'd end up at my y-intercept. And it's really easy to find the y-intercept. How do you find the y-intercept of any equation? You set x equal to 0 and solve. So if you were to plug in a 0 here and a 0 there, everything becomes 0 except the minus 5. So you get the actual coordinate 0, negative 5. 0, negative 5. And you get your y-intercept. So, I mean, I could have used the pattern 2 over 12 down. Check it out. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get to that point anyway. Then you map it over to the other side. 1, 2, right below the vertex. 1, 2, and you are good. There's your parabola. There's your 5 points. Look at this one. Has an a value of negative 1/4. Definitely interesting. Let's find the vertex first. For the sake of space, I did the formula over here. Identify your b value being 3 and your a value being negative 1/4. So you could actually do all of this directly on a calculator. Let me show you. So the parenthesis buttons are right here, the negative sign's right there, the fraction button's right there. Just type it all into the calculator. You're going to get positive 6. So using the calculator, we got a positive 6 as our vertex. And then you plug it in to find your y value. So when you plug it in, rewrite your original equation with parentheses. And you plug in that 6 into those parentheses, then you do the math. 6 squared is 36. 36 times negative 1/4. That's like saying 36 divided by negative 4. You could use a calculator. That would be a negative 9. And then 3 times 6 is positive 18. And you bring down that minus 1. You get a 9 minus 1, which is 8. So our vertex x value is 6. Our y value is 8. So let's go to the location 6, 8. 6, 8, and put a dot right there. And then from that dot, we want to use the pattern, and it's opening down because the a value is negative. However, you can't use the pattern 1, 1, 2, 4, 3, 9 as is because the a value is negative 1/4. So you have to multiply the outputs by negative 1/4. Now this is very important, so please pay attention. When you multiply 1 times negative 1/4, you get a negative 1/4. And when you multiply 4 times negative 1/4, you get a negative 1. And when you multiply 9 times negative 1/4, you end up with a negative 9/4, which is negative 2.25. However, we know that on quizzes, it doesn't let you go 2.25 or any decimals or even fractions. So the only part of this pattern that actually helps you is the part that says 2 to the side and 1 down, okay? Now, yes, it's true that 1 to the side and 1/4 of the way down works. 1 to the side, 1/4 of the way down would be right here, and that's what the parabola looks like so far, but you cannot go 1/4 of the way down on quizzes. So we're going to only use the nice part of the pattern, the 2 to the side, 1 down. So 2 to the side, 1 down, you're going to put a dot right there. Whoops, I'm doing red. And you're also going to map that to the other side, put a dot right there, and that's what your parabola looks like so far. Now, it says plot 4 points. We only have 3 points. We need another point. How could we find another point? Well, you would go to an XY table and plug in another x value. Now, when you have a standard form quadratic trinomial, the easiest x value to plug in would be 0, finding your y-intercept. Finding your y-intercept, all you got to do is plug in 0 into your x's, and these x's make everything disappear because if we plug in a 0, 0 squared 0, 3 times 0, 0, everything becomes 0 except the c value. So when you plug in a 0, you get out a negative 1 because the c value in this case is negative 1. And that tells you where it crosses your y-axis. That's your y-intercept. So 0, negative 1 is right here, and you put a dot there. Now, if this graph were big enough, you'd be able to say, I want to map it over to the other side of the axis of symmetry, 1, 2, 3, 4, 5, 6. But when you go 6 this way, you're off the 10 by 10 graph, so you don't have to worry about it. That's why it only says plot 4 points. And we have 4 points. Again, we're going to start with the vertex. I'm just going to put V for vertex. How are we going to do that vertex? You're going to use a formula x equals negative b over 2 times a. When you use it, rewrite it with parentheses, negative parenthesis, over 2 times parenthesis, and identify your b value of 4 and your a value of 1/2. So you put a 4 right there and a 1/2 right there. Now let's do the math. You get a negative 4 up on top, and you get a 2 times half is 1. So you really have a negative 4 as your x value. And to find a y value, you plug in the negative 4. So we're going to rewrite the equation. Y equals 1/2 x squared plus 4x plus 5. And we're plugging in the negative 4 right there and right there. You could use a calculator, but negative 4 times negative 4 is positive 16. When you multiply that by 1/2, you get 8. When you got 4 times negative 4, you get a negative 16. Then you bring down the plus 5. So when you go 8 take away 16, that's negative 8, and negative 8 plus 5 is negative 3. So your vertex is negative 4, negative 3. Negative 4 on the x, negative 3 on the y. You put a dot there. That's your vertex. From that vertex, it would be nice to be able to use a pattern 1, 1, 2, 4, 3, 9, but we know that that pattern only works when you have an a value of 1 or negative 1. In this case, you have the a value of 1/2. Which means you have to multiply the outputs by 1/2, by 1/2, by 1/2. And again, on paper, it's great, but right here on quizzes, it won't let you go halfway. For example, right here, 1 times 1/2 is 1/2. Right here, 4 times 1/2 is 2. And over here, 9 times 1/2, if you do it on the calculator, it ends up being 4.5 or 9/2. So the only one you could use on quizzes, because like if you try to go 1 to the side and halfway up, what's going to happen? You go 1 to the side and you're going to try to stop right here, but on quiz it's going to bump it up to the next nice point. So you can't stop halfway up. On paper you could, but right here on quiz you can't. So 1 to the side halfway up doesn't help you right here. It won't let you put it right there. So you're going to have to go to the next one that actually works. 2 to the side and 2 up. That one's nice. So you can go 2 to the side and 1, 2 up and put a dot right there on quizzes for sure. And then you go back to the vertex, 3 to the side, 4.5 up. 1, 2, 3 to the side, 1, 2, 3, 4.5. It's not going to let you stop right there, so that doesn't help you either. But at least we could map this over to the other side of the axis of symmetry. 1, 2, 1, 2, put a dot on this side. So far we have 3 dots, but the problem is they want 5 points, right? So I need another point, which is another easy point to find on a standard form quadratic trinomial. Finding the x-intercept, right? The x-intercept is the easiest thing to do. How do you find it? You set x equal to 0 and solve. So if you put zeros right here where the x's are at, we're going to find x-intercept, which is a coordinate 0, comma something, because you're setting x equal to 0. So you put your zeros right here. 0 squared is 0. 4 times 0 is 0. 0 plus 0 is 0. 0 plus 5 is 5. So you just found out that it crosses the x-axis at 0, 5. 0, 5 is right here. Put a dot right there. And now you have 4 points, but you need 5. So take this x-intercept and map it over to the other side of the axis of symmetry, which is a vertical line passing right through the vertex. 1 unit, 2 units, 3 units, 4 units. That's directly on top of the vertex. 1 unit, 2 unit, 3 unit, 4 unit. Put a dot right here. And voila, you have your 5 points. 1, 2, 3, 4, 5. It's asking for 5 points. There's your parabola. I hope that makes sense.